Hello everyone. Welcome to this stream, episode number 5 of the series of Tuesday Night Live with myself and Emanuele Bonin.
Hi all.
This series is brought to you through Phaze101 and Retro Programmers Inside. So, as you all know, I always start with this. Please subscribe, like my YouTube channel, okay? And like the videos. This is how I manage, or YouTube manages to share the videos. Please read the comments under the video, okay? There are links under each video for this series. For each video has got a link for the source code and any other links that might be useful. That's some things that we mentioned in relation to in that stream, basically. So please do that. Of course, please subscribe to the Retro Programmers Inside channel, YouTube channel, and also like their videos. Please know that I am subscribed to their channel, just I'm not logged in. Okay? That's why it is like that. Please follow me or follow Phaze101 on the Facebook page, sorry. I always mix this. Also, to make it even worse for me, Facebook is changing things, and just before the stream, they invented this icon now. Oh, it's not there. Hold on, let me refresh. Because there was a different icon a minute ago. There you go. To switch, there is this icon now, but I think if I do this, I see the old one, at least. But yeah, to confuse me even more. So please like, follow. Hello Arturo. Please follow the Facebook page. Of course, follow also the Facebook page of Retro Programmers Inside. Subscribe, like, Same thing, subscribe to the Phaze101 Facebook group, but also subscribe to Retro Programmers Inside, which I forgot to add the link today because of all the mess that I had before I started. And also, for those that do not know, I have the other group, Commodore Dev. So please subscribe to that group. It's anything related to Commodore. For those that want to get in touch with me, Discord is the place where you should be in, where you should write to me. You can write to me on Facebook, but Facebook I'm not there as much as I am on Discord, also because it's easier. There's also things related to RPI, Retro Programmers. There's also a channel dedicated to them. Okay, so eventually you're going to see the games, like, you remember there's a game jam going on right now, the PONG Game Jam, and you will see the games being shown here. You can also get in touch with me on Telegram, just the Facebook group, Phaze101. If you like what I do and you want to support me, then you can have a choice between Patreon and Coffee, and right now there are 64 videos to unlock, but in reality it is much more, because there are things that I've edited and I haven't approved them yet, but there is more. So it's the same thing. It's a copy of, Patreon and Coffee are the same. Okay, there's the same things on them. There's also, well, I have this shop for those that want to, buy merchandise related to Phaze101. But what I wanted to show, I went on this page to show it to Emanuele. There is the commands for the stream. If you want to learn how to use the stream, and you can see also the points, the points table, where you are in the points table. As a reminder, I have this page for those that follow me on the for the Amiga series, Friday, Saturday, Sunday, where you have links to be able to code for the Amiga. Note also, and please go and read the text. I've released the source code of Mr. Pujerny. You can download it and you can try to make a game from it, which today I will show. I will show a game made from this game. Okay, so for me it's always a pleasure to see such things. So yeah, I will be showing the game in at around 9 o'clock. For those that are on this stream, first I need to change to, for those that are on this stream, I'll give you some points so that you can use them on the channel. By the way, there is a hidden icon on the screen, which is on top of the chat, which is the boss. Okay, right now I have the boss in my hands, but you can fight and get that. You're working on the game while listening. Okay, so you're improving it. Okay, perfect. By the way, the game was done by Andy. I was going to mention it later on, but the game is done by Andy, and I will show it, let's say, in between things, which is in an hour's time. I also have another game to show. It is not my game or somebody. It's a game that I participated in a stream, and I will show this game because it's quite cool. So, and as you see, from today onwards, you'll be able to see myself. And if I don't want to show myself, I can also change the background if I want to. So I can have a demo behind me if I want to, or the Phaze101 logo. I think the demo is too distracting. At least this is what I was taught. So there will be just the logo, and I can vanish too if I want to. Okay. So yeah. Okay, so as you know, this stream is about coding for the Commodore 64. So yeah, Andy, if my presence annoys you, I vanish. I become a ghost. I have 3 monitors in front of me, okay? So one there, one here, one there. So when you see me looking, it's because I'm switching from one to the other. That's the main reason. Most of the time I will be looking either in front of me or this way, but sometimes I look that way. Okay. So today we continue with the series that we are doing in programming the Commodore VIC2, okay? And last Tuesday we started on how to create a stable raster line on the Commodore 64. So today we continue with this series. We haven't finished the code, and Emanuele will repeat that. I have to admit, because of the trouble that I had before I started the stream, I had no sound basically. I didn't get time to correct the English or make it better, let's put it this way. So please be gentle with Emanuele, okay? Remember, he's Italian.
Please.
His English is not, it's not his main first language like myself, but because I'm in UK, maybe I'm a bit faster. So please be gentle with Emanuele. And anyway, I will repeat what he says so that if people did not understand correctly, I correct that and make them maybe understand better. Although sometimes I'm not paying attention myself, and I will ask Emanuele what did he say. Emanuele?
Okay. Thank you all users. Okay.
So you can start, Emanuele, and please start again from the beginning and ignore the fact that we did part of it last Tuesday.
Yes. But before that, I want to remember you to give points.
I gave points today, so yeah.
Okay.
I
Another
remembered.
Okay. Another thing is I want to say again thanks to Phaze for the occasion to do this live together on your channel.
That's okay. You're welcome.
Okay.
Oops, the light is not a good idea.
Let's start. Have I control?
Sorry?
Have I control of share?
Yes, I'm following you. Yes, you have control of Visual Code.
Okay. Sorry. Another thing, Phase. Can you show the unstable line and the stable line before all?
We have that is in a different. We only have 401 here, Emanuele. I cannot.
Okay. Okay. Don't worry.
Start explaining, and I will think about something. Start explaining, and I will think about something. Okay.
Okay. In the previous examples, we have seen a raster line was shown at level at row 13. As you have noticed, the line was unstable. It moved every frame, causing flickering. The flicker is due to the fact that the interrupt that displayed the line may be requested at any time, even when the CPU is in the middle of the completion of an operation, or an opcode, basically. In this case, most of the time, to tell the truth, the CPU completes the operation that was doing it before, serving the and after it serves the interrupt call. This delay is unknown at the beginning, as known as jitter. It causes uncertainty about the exact moment in which the interrupt is handled. Hence, it results in flickering in our example.
Emanuele, I think I managed to get it to work. So give me a second. I will show the unstable interrupt, unstable line. Okay. So as you can see, we have an unstable line. We are changing the color to gray, okay? And then we are changing it back to blue, okay, on the same line. But as Emanuele will explain, or this is happening because the instruction, I don't know if you arrived there or not. Yeah. We are in the middle of an instruction, so it is not always in the same place. That's why.
Yes.
Okay. So this is what we did last week. Okay. You can continue, Emanuele.
Okay. Can you show the stabilized
This one?
version of
Yes.
this
Stabilized? Yes.
to
So
show what we wanted to reach?
yeah. It's a good idea. We always need to do this. So okay, so as you can see, the line is stabilized now. Okay?
This is our goal.
Yeah, that is our goal, exactly.
In this case, the line start every frame in the same place of the raster line.
Okay, is it okay to close it?
Okay.
Okay.
Can I continue?
Yeah, and you have
Okay.
control. You have control, so it's okay.
Okay, thank you. I wrote an example here. Considering the next 4 lines of code, there is a first of code of CLC that clear the carry and occupy two cycle of clock. After that, there are some other instruction like LDA, load accumulator from the start of the video, add 42x to the accumulator, and store it in another place of the memory. If the interrupt occurs exactly between the end of CLC, for example, and starting the LDA, the second opcode, the jitter, the uncertainty will be 0. The interrupt will be served immediately. But if an interrupt occurs in the middle of this long consuming cycle instruction, the interrupt will be served after from 1 to 4 cycle
After the instruction has
after
finished.
it occurs.
Yeah.
I repeat, when reading, when an interrupt occurs, it can occur between two entire opcode, like the interrupt number 1. The interrupt is served immediately with a delay of 0 cycle, so jitter is 0. If an interrupt occurs during an opcode which hasn't finished, like interrupt number 2, assuming that interrupts occurs after the first cycle and before the last one, the fifth one, the interrupt can be served with a delay will have a range from 1 to 4 cycles. This causes an uncertainty or jitter. In the ASM 6065
6502, yeah.
okay, there are many type of opcode. It can be you consume from 2 cycle to 8 cycle. So the gitter can be from 0 to 7 cycle at maximum. The stabilization of the interrupt allows you to completely clear this uncertainty. Therefore, you need to know how many clock cycles the raster is from far the left. Sorry. Uh, Clearing this uncertainty allows us to start drawing our line at a
I missed who
specific
did the
point.
wow. I missed who clicked the wow, but thank you very much. Yeah, continue, Emanuele.
Okay. Clearing this uncertainty allows us to start drawing our line at a specific point, like in the example, in the
Oh,
raster line, without flickering.
welcome to the stream, Oscar.
Oscarius.
Yeah, Oscar. Yeah,
Oscarius
welcome to the
is,
stream.
Oscarius is my son.
Really?
Really.
He's
It
testing
found
your English, but I want to hear his English. Okay.
Thank
Joking
you.
apart.
Thank you.
Hello, Oscar.
Okay. It must be said that the stabilization of the raster is not always necessary, and often it is sufficient to have an approximate stabilization. For example, if you want to open the upper and the lower border, you shouldn't have is not need the exact stabilization. Okay.
So,
however, if
I will explain again what you said up there, so then you can start with the code. Okay. So I'm going to take control of it. Okay.
Okay.
So you can rest a bit. So. Okay. So I'm not going to read the notes, but I'm going to tell you the most important things, okay? So what Emanuele was saying is that, as you saw in the previous episode, we have jitter, okay? Jitter is, the line is not stabilized and it's like flicker at the edges, let's put it this way. That happens because an interrupt can only be executed when the instruction happens, okay? So, if say the interrupt happens after the CLC, okay, so between the CLC and LDA, then there is no delay and it is at 0 and the line is perfect. But if it happens, say, in the instruction STA 0400, okay, comma Y, that instruction is 5 cycles long. So if it happens in the first cycle, then you have 4 more to wait. The interrupt has 4 more. So it is this which causes the line to it is this that causes the interrupt, let's put it this way, to, when it's drawing the line, because it's not precise, to cause that bit of shift either before or after, as you see it. However, what Emanuele is going to show is that we can eliminate the jitter and control when this happens. So like that, we always have a stable raster line. And this technique is quite important to know because there are some tricks that you need to know this to be able to do that, to do it, to do what needs to be done. So yeah, it's this is the initial, let's say, because Emanuele has got 3 sources today. I don't know if we will manage to show them all, but there is quite how to say, there's quite a bit of learning curve to do today. You might get tired, so that's why in the middle we break up a bit, because it's quite you need to be concentrated. So please concentrate on what Emanuele is saying, okay? Because it's very interesting, and I have to concentrate too because I will have to repeat it. So yeah, Emanuele, I gave you control. You can continue.
Okay, thank you. Okay, here we have some constants that commonly we used. Uh, uh, this is our goal. This is our raster line to reach 13. But if we make stabilize the raster in this line, in order we need to start the stabilization procedure to cycle before that. That is raster line 28. In fact, we define another constant called RST underscore my ERQ. ERQ. Okay. Yeah, there are some other some other constant for the VIC register. DO12, the raster counter register. DO11, the control register 1, bit 7 used for raster counter for the raster line greater than 255. Here we have the VIC ERQ flag register. We said after the use of it. And the VIC ERQ control register DO1A for to setting the raster. Okay. First of all, we disable all interrupts. This is is the same code that I used in every place where I use raster interrupts. So I load a value to deactivate the interrupt for the chip CIA 1 and 2. I use this mask to disable 2 interrupts here. I load this value in the accumulator. So with these two simple loads, I clear any raster interrupt eventually queued in the CIA 1 and CIA 2. Now I switching off the kernel and the basic ROM, so I will have all 64 key RAM memory for my program. For my programs. Okay. In order to make this, I load this value that is a value where any bit have the have a meaning to say which part of the Commodore 64 could be switched on or switched off, and what part of memory I will use. I store the value in the ST in the second byte of the memory, or the byte 1 of the memory, that is the configuration byte of the Commodore 64. Is very important, this byte. After phase, I'm sure that show you better this
Hello, Docster.
this thing. Okay.
Emanuele, do
Sorry.
till you load the interrupts, okay? Do till this part, okay?
Okay. Okay. Yes. Yes. Okay. I load here. I have I load the low part and the upper part of the address of my pre-interrupt routine. Why pre? Pre because I'm using a double interrupt trick to stabilize the interrupt. This this thing is useful to stabilize the interrupt. In order to make to do this, I must use two interrupt, one next the other. Okay.
Okay. I'll take control, okay, Emanuele?
Yes.
Okay. You can have a drink, okay? Not alcohol
Yes.
though, okay?
Uh,
So, in the beginning, we have some constants, okay? So, we have the raster line where we want our line to be drawn, okay? But as Emanuele will explain or have explained, we need to start controlling this 2 lines before. No, I cannot code with a beer, Andy. No, I will not code at all. I just have water here. So, as you know, the registers, there are 2, okay? This is the register where we have, actually, both of them, we remember the raster line is not from 0 to 256, but is from 0 to 312. So there is the high bit in DO 112, or sorry, in DO 11. We have the IRQ register and the other. Actually, I didn't prepare it today. Actually, let me show you what I am talking about, or what Emmanuel was talking about, because I will, let me find it first and then I show you. So DO19, okay. There you go. It's the interrupt status register. So this is why here, and there are these bits that can do several things. We are interested in the first one, bit 0, which is an interrupt related to the raster line. Okay? The others, which is sprite, background collision, sprite to sprite collision, and light pen, we are not interested. We are not interested on these today. So that's the 019. Then there is the 01A. Here you say what interrupt you want to enable. Okay, so here which interrupt, which interrupt happened, and here is which one you want to enable. So this is why there are these two registers. First thing he does is switch off the interrupts, then he disables the CIA, okay, CIA1 and CIA2, okay, and clears the interrupts, okay. This is clearing the interrupts. By the way, I was not paying attention, but at least this part of the code I can read it. Then Emanuele switched off the basic ROM and the kernel, okay? This is important for our case because like this, we can reach these two memory locations and change them, because before we could not do that. And for those that do not know what that memory location is, given that I managed to scroll down till the end. So FFFE and FFFF is our execution interrupt address, what the interrupt execute. Okay, so it's the jump address that the interrupt does. So we will be changing this. So what did he do? He loaded, okay, we have a routine here, okay, called pre-my-IRQ, and that is further down here. This is the first interrupt routine. Okay, I use the word first, but listen to Emanuele. This is the first interrupt routine, okay? So he load the low byte and high byte into A and X, and then he is storing it in the memory location where the jump address of the interrupt is. So he's storing it here, okay? This is quite important, okay? So because before we could not do it when we had basic on and kernel on. So me, okay, Emanuele knows this very well. I am one of those that I hate the basic ROM of the Commodore 64. I love the Commodore 64, but not its basic. Okay, first thing I do, I shut off basic and kernel. Bye bye. Okay, I want control of the Commodore 64 because it's nicer. Okay, the Commodore 64 without its basic and kernel. So that is me, and yeah. But Emanuele knows very well this thing of me. All my code starts with this basically. Yeah, it's evil. I love the Commodore 64. I really love the computer, but its basic drives me nuts. It's better without it, I think. Anyway.
Bye, Doctor.
No, he didn't mean buy. He meant buy for the word that I used. But anyway.
Okay, sorry.
Yeah. So I pass it back on to you, Emanuele.
Okay.
So you can take control of where you left, which is this part.
We start from here.
Yeah.
So the pre-MyRQ low and high byte, like James said, will be stored on these two in these two memory address where the interrupts read the address to execute when the interrupt occurs. So after that, we said to the Commodore 64 what type of interrupt, where the interrupts we want to occur. So we set in the raster line interrupt using the DO12 register. So we load the RST IRQ value, that is 28, if you remember. That is two lines before our goal, that is 30, the 13th rows. Okay. And we store the value to the DO12, that is the register for the lines that are from 0 to 255. So we are going to set the bits number 7 of DO11 to 0, because that is the bit to be able to count the raster line when they are over 225. In this case, our line is under this value, so this bit it must be reset or set to 0. We made this into these 3 lines of code. We load the DO11 register value. We make an endwise bit to reset the bit number 7. Okay, and we change the DO11 value. Okay. Now we set in DO1A. This is important to say to the Commodore 64 what type of the ERQ we must use, because it's not scontato, come si dice?
Say it again.
Scontato, non è...
do not take for granted, basically. So he needs to set the interrupt. He needs to tell the Commodore 64 that we need the interrupt related to the raster line, basically.
Okay, because there are many type of interrupt that
Yes.
C64 can be managed. There are interrupt for the raster line like this, for the light pen. Now with the LCD screen or LED screen, there is no this need. But there are interrupt for the collision of sprite to sprite and another sprite to the background. So we must say to the C64 what type of the interrupt we want to trigger, and call our pre-MyRQ routine. So in our case, we want a raster line interrupt. To reach and this type of interrupt is necessary to reach the interrupt when the raster line reach the line 13. Okay. In order to do this, we load in accumulator the value of 1, basically. that is the first bit set. The first bit said to the Commodore 64 that we are interested on using ERQ of raster line. So we store the value to our DO1A register, and now we can enable again the interrupts. After that, our Commodore 64 will call our routine every time that the interrupt will be triggered. Okay. Now here is a simple loop that emulate the operating system, because there is no operating system. We have switched off the two ROMs, basic and kernel. So we can't we have no we can't return to the operating system. No longer exists. Okay, so we have an infinite loop that increment the upper left corner of our video to show us that the computer runs.
Okay. Okay, I can give you a rest. Okay? So,
Thank you.
I'm going to take control.
Yes.
So, what Emanuele said is that once we set our interrupt routine, once we tell the Commodore 64, hey, this is where our interrupt routine is at these addresses, okay? We need to tell the Commodore 64 where and what we need in terms of for the interrupt to happen. So here is the line 28, which is 30 minus 2, because remember, you need to start taking action, two raster lines before the line that you want something to happen. So here we have 28, and we store it in the DO12, where you tell it which line you want. Okay. Also, we need to make sure that bit 7, which is the high bit for the raster line, okay, for this register basically, is set to 0. He does that by using an AND. So, like this. Dockster! Oh my god, Dockster! Oh my god, Dockster, thank you very much. Oh. Dockster. Oh my god.
Thank you.
Thank you very much, honestly. So, so you gave a sub to Bip Y. Oh, hello, Bip. I didn't realize you here. Hello. You gave a sub to Bip. One to Andrea, one to Ozzy, one to Giuseppe Verdi. Oh, Giuseppe, you are converting yourself into retro. Forget, Giuseppe is crazy on Rust. I do not like Rust. Anyway, welcome guys, and Q Continuum. I do not welcome to the stream, and Dockster, thank you very much for the subs. So, to make sure that the high bit is set off, he uses an AND. We use an AND to set a bit off. So this is what he's doing here. Then he tells the Commodore 64, hey, we need interrupts related to the raster line and to the raster line where we specified here. Okay, so he is setting the interrupt to where the interrupts needs to start happening when we reach that line, basically. Then he enabled the interrupts, okay? And because we have killed the OS, okay? The OS is not there anymore. We told it bye-bye. We have to create an infinite loop, and he could have done an infinite loop here, but he's incrementing to show that something is happening on the screen, okay? So this is why I have an increment of 400. That is to show that we have something on the screen. And just to remind you, this is what we are building. So notice our line is stable, okay? Previously, this line was moving left and right, okay? There was jitter in it. This is emulating the OS that is still running, okay? But it's just that infinite loop that we have here, okay? That I cannot show right now. Oh yeah, this infinite loop. So we will achieve this. Yes, it's a stable raster routine. And we will show you what you can do once you get the stable raster routine working. Emanuele has got some examples. One thing that I forgot to mention is that this raster is happening in the between 0 and 255, okay? So this is why he had to set, where was it? This is why he had to set this bit off. I killed the Commodore 64. This is why there's a 0 there, because if we wanted the raster line to be down here, then the high bit needs to be set, okay? So, how long is this? Emanuele, I'm going to talk about the game jam and about the other stuff that I need to show, and then we can continue with this part, okay?
Okay.
So, for those that do not know, me and Emanuele were the founders of Retro Programmers Inside, okay?
And other, not only we.
No. We started, but then there is more people behind it, and I, because I wanted to concentrate on Phaze101, I went a bit on the side. So, the group, and I am still involved on the group, just I do not administer the group. I just leave it to them. So, the group, where is it? Here. So, the group organizes game challenges, okay? It's just for fun we do this, okay? There is no, you know, like you don't win anything, except that in the end we show these games in this stream, okay?
Sorry, James.
That's okay.
There is one thing that we can gain the infinite glory.
Oh yeah, well, yes. So we don't give any, you know, any winner. We don't give a trophy or something like this, but we show the games at the end in this live stream. This game jam finishes on the 30th of June. Okay, why we decided to do this game jam? Because it's the 50th years anniversary of Pong. Okay, that's why we did it. Emanuele is a game programmer or coder.
In my life, I'm a programmer. With retro, I'm a lover of retro.
Yes,
and,
we are all retro lovers.
I love code. I love code anything on retro.
Yeah, we are all retro lovers, especially with all the respect to the others for the Commodore 64 and me for the Amiga, of course. And a little bit of Mega 65, which I still have to do more things on it. But anyway, after this challenge, there will be another challenge, okay? And it will be also for another specific time. And I already know what challenge there will be, so don't ask me, but I'm telling you I know because I'm organizing this one. What? Really? No. Ozzy, are you serious?
Wow, is a beautiful
How can a game like that be reviewed?
is a beautiful news.
I mean, the aim of it was for others to learn. No. Wow. Okay, I had no idea. Yeah, I will check it out. Anyway, so the in the front cover, you're joking.
You are famous now.
Okay. Anyway, let's continue talking about the game jam first. But thank you, Ozzy. I will check it in a minute.
James,
So
you are losing your head now.
no.
Hey,
No. I have just one aim to make others code for the retro machines that we all love. That's all I have. And that's what gives me pleasure. So when I see somebody using either my code or learning from what I teach, it is the biggest, trophy that I can get. Thank you, Docstar. Thank you. So, this challenge is going to finish on the 30th, and on the 5th of July, we will be showing all the games. Okay?
Yeah.
Some of the games you can already see screenshots of them in the lower right-hand corner of them of the screen. So normally it's fun. You see me. People make fun of me playing because I'm not a good player, but anyway, it's part of the fun. Okay, so that is Pong, and I remind you, those that participated, to submit the code, I mean the program, to Emanuele. There's an email that you have to send to. Okay. Besides that, I want to talk about this. When it starts. Okay, so yeah, that's true. I'm a bad player. Yes, I play games, but I'm a bad player.
Our goal is to bother James.
Yeah. They boo me. Yeah. If I was in front of them, I think they throw eggs. But anyway. Hi, Duncan. Welcome, guys. Follow Duncan. He does cool streams. I might be taking part on one of his streams, just to make you aware or gives you a heads up. It's still not yet decided, but yeah, please follow Duncan. He does cool things. Normally he does things related to, games, retro, and also cartoons. I like cartoons too, so there you go. A combination of both. And he has something special, okay? Look at his last word in the title, Malta. Okay, he's Maltese like me. Originally Maltese. So why I'm showing this? So Andy, okay, who is on this chat, started coding for the Amiga 2 weeks ago. Sorry, 2 months ago. Okay, and he managed. So this game is available for the Apple iPhone on iOS. Okay, he converted that to the Amiga. It's not yet 100% ready, but it's there, and I'm going to show you this. Oh, thanks, Duncan. Now, notice one thing. He mastered sprites multiplexing on the Amiga. That is something for me. So, in my code that I did for Mr. Pooh, okay? Because he used that code in it to create this game. I did not use multiplexing, and he is using multiplexing here to have all these sprites. Okay,
It's
so
very cool.
sorry.
It's very cool.
Yeah. It's very good. Yes, this is for Amiga. Yes, it's not yet Dockster. It's not yet ready, but this is a big, how to say, a big. Maybe you missed the previous one where I showed the earlier version of this, but this is a big improvement from what it was. So yeah, before he did not have multiplexing, sprite multiplexing, and because of that he was only limited to 6 sprites. Now he has quite a bit, so it's quite cool that he managed to do this. Yeah, it's getting there. What is impressive, and Andy, I'm serious, that in 2 months you achieved this just following my code. So yeah, it's really impressive. So I don't know how to look for Amiga. So I don't know if they are Amiga Passion. Amiga Passion Italy. Is it the Italian version, I assume? So do you have a link, Ozzy, where it is? I will. Where can I look for photos? No. But this is Amiga Day, no. Amiga Fashion Magazine. Where the heck? So, La Rivista. Okay. But I don't see it. Yeah. Oh my God. Yeah. It is mentioned there. It is mentioned there. I cannot believe it. Oh my God. I have to thank them. Oh my God. Well, there you go. Wow. Oh my God. And it's even mentioned here. I'm realizing here. Look.
Hi,
Wow.
Andy Mason.
Ah, thank you, Andy. Wow. Wow. This is it's being distributed on the 1st of July, so it's not out yet, but it's going to be. Wow. Wow. I just don't know what to say right now. Yeah. Okay. This is the same. You know, when I released it, there was someone that did a video of it, and I said, "What? A video of this game?" No. Okay. Anyway, let's continue because I uh, I really don't know what to say more. No, I'm not losing my head. Emanuele. Thank you, Fraxin. And thank you, Ossi, for letting me know. I will buy it. I will buy the magazine. I mean, I bought. I didn't buy it. I don't buy it always, but I did buy um, in the past. So yeah, okay. Thank you, Doctor. How did they find out about it? That is because I only released it like 3 weeks ago, and you know they prepared these things quite some time ago. But okay. Emanuele, I give you control,
Thank you.
and there you go. Pre-my
Okay.
RQ. But before you continue, pre-my is here. Okay, so this is the first interrupt that Emanuele is going to talk about. Okay, this pre-my RQ.
Yes. Yes.
Thanks, Andy. Funny enough, I'm planning a trip to Italy. Funny enough. Good one.
Okay. Uh, Now we can start explaining the pre-MyRQ routine. That is the first routine that is called by our interrupt. Um,
Cheers,
in this explanation,
Dockster. Cheers.
okay.
So sorry, Emanuele. Sorry.
No, no, don't worry, don't worry. In this explanation, I'm using an annotation because in order to stabilize the raster, we must count the every single cycle of the opcodes where we will using. Um, the annotation that I used, that I will use, is like this. If I if I write R15 space C 20 minus 25 indicates that raster line 15 and the cycle between 20 and 25 are the cycle involved in that lines. The numbers in square brackets next to the opcodes indicate the cycle used by opcodes themselves. The number after the arrow, the little arrow, indicate the range of finish cycle. Saving the start. Okay. Now, first of all, we save the status of the CPU register. So we save the accumulator. We save with these two extraction the X register, and we save with these two extraction the Y register. We can save the accumulator with one only extraction in the stack, but there is no an opcode to save the X and the Y register directly to the stack. So we must pass through the accumulator, transferring the X and the Y value to the accumulator with the TXA or TYA, and and so using the PHA to save the accumulator value to the stack. Okay. How you can see here that there are the various
Of the cycles.
consuming yes, sorry, the various cycles used by that instruction. Now, okay. First of all, I forgot this. When Premiere MyRQ start, I'm sure that it start in row 28, but the cycle where is starting can change from 7th cycle and 14th cycle.
Can be between 7 and 14 because we do not know where it is exactly.
Okay. This cause I will say now with this summary that I wrote. Okay. In summary, a normal raster line use 63 cycle to draw all the screen. In the PAL version of C64, that is the system that we use normally. When the interrupt is trigger, sorry. Okay.
Read your notes, Emanuele.
Okay. when the problem is another, I lose my my voice. When the interrupt is triggered, first of all, it uses 7 cycle to save itself its status. Okay. When the interrupt is called, it save on the stack some things.
So let me explain this because this is difficult actually. So when an interrupt happens, okay, and you can have a drink, Emanuele. When an interrupt happens, okay,
thank you.
Automatically, okay, the CPU saves the status register. It's done automatic. When an interrupt finishes and you return back to the OS, okay, the status register is restored, and this is done automatically by the Commodore 64. So you do not need to save the status register, but we need to save the other registers, and this is what Emanuele has done here. However, to save the status register for the interrupt, to save this up, it takes 7 cycles. That is a known fact. Okay?
And it saves the address to come back
Yeah,
to
just on the stack.
on the stack. Yes.
Yes. So that's why 7 cycles. It saves the address where it was, and it saves the status register.
Yes. Yes. Okay. Other cycle that can change from 0 to 7 are used to complete the last opcode operation, possibly interrupted by the interrupter. Like I said before, the interrupt can occur in any moment. So it can occur in the middle of an opcode. In the C64, the littlest, posso dire the littlest per dire il più piccolo?
In quale senso?
Il più piccolo, quello con
The
meno
least,
cicli.
the smallest. You can say the smallest.
Okay, the smallest consumer opcode is
you can say the opcode with the. Well, I will complicate things. I think. Continue as you are. I'm going to complicate things. No, ignore me.
Okay. The opcode with that use littlest cycles uses 2 cycles. The bigger one uses 8 cycles.
Okay, let me explain this. So there are instructions that take 2 cycles, and there are instructions that take longer. Okay, the minimum that you can have is 2 cycles. Okay, the maximum can be 5, 6.
No, 8.
8? Okay, 8. The maximum is 8. So
okay.
Yeah, he continues now. Yeah, continue.
The maximum is 8. So the number of cycles that the interrupter can use to complete the last operation can be 0, from 0 to 7 cycle. This is why the guitar exists. This is our goal, to play, to zeroing this guitar. And other cycle are used before our routine will be called from the interrupter. The other cycle are 13 cycles to save the various register and status processor. No, sorry. Okay, I inverted the two things. The first 7 cycle are used is not for the status register. Sorry, I inverted the two things before. The first 7 cycle are used only for the address to return back.
Yes. So yeah, you mentioned this. I think you forgot.
Okay.
The 7 cycles are for storing the address, the jump address, so that the CPU can return back to that address. No, you mentioned this.
Yes, and the last thing is the 13 cycle used to save value register and status processor in the stack.
Yeah.
Okay, so we are in the row 28 with in the cycle that can be 20, 21, 22, 23, 24, 25, 26, or 27. This is the indecision. Okay, these are the 13 cycle that I use. Okay. Okay, these are used by the interrupt. These are the
Yeah. So what he's saying is the first 7 cycles are used by the interrupt. The 13 cycles, okay, are these up here. Okay. So this is our code, the 13 cycles. But 13 plus 7, no? So those 7 cycles is the jump and the save of the status register. That's
yes. Here there is a typo. Here.
yeah, don't worry.
So we this when we are here, we have a degree of impression jitter of 7 cycle. We must have a degree of precision equal to 0.
Yeah.
Okay.
So
Now,
basically what he said, you can stop here. I'm going to give you a break. We are
okay.
we are still on line 28. Remember, we started on raster line 28. Okay? So what did he do? He, as soon as the interrupt starts, the interrupt consumes 7 cycles. Okay? That is for the address and the status register. Then there are 13 cycles, okay, that are for saving the registers. This is the part that we need to do. We are still on raster line 28, okay? And we have, by doing this, we are somewhere in between 20 to 27. It depends where it happened, okay? So right now, we don't have a stable raster, okay? And it can be offset by these 7 cycles. So this means that we need to do something to get it to 0, okay? To correct these 7 cycles. It could be 3, it could be 7, it could be 4, whatever. But we need to correct it somehow. And Emanuele is going to explain this part, the correction, or the start of the correction.
Yes, I'm trying to.
Yes.
Okay. We now we are inside an interrupt routine. So the first thing that an interrupt may do when it called is disable interrupt. So we cannot annihilate interrupt on interrupt, or better.
Okay.
Normally,
I'm going to stop you here because this is important. So what he's saying is that once we enter our interrupt routine, there is nothing stopping us from having another interrupt. Okay, so he is going to create another interrupt within the interrupt routine. Okay, because the system is executing an interrupt, but there's nothing stopping the OS from sending another interrupt. And if it sends another interrupt, we can take advantage of that. So, Emanuele?
So now we have interrupt disabled by the system, but the trick is to control them and make sure the interrupt fires in the next raster line. Why? Because in this way we can manage the jitter. We will simply wait for the interrupt on the next raster line. We are in the 28th raster line, and we want to trigger an interrupt on the raster line 29. We will simply wait for the interrupt and make it happen at the point where is the NOP command. Why? this is in this way the jitter will be only of one cycle. This because if we must assure that an interrupt occurs in the middle of an opcode. An opcode is long 2 cycle. If the interrupt is triggered in the middle of or at the beginning of the NOP time, we have a jitter of 1 cycle only. So the jitter is reduced from 7 to 1 cycle. This is the first goal that we want to achieve. Okay. So we are on the raster line 28. We continue to count our cycle, and first of all we load the second raster, second interrupt routine address on the FFA and FFFF. We load our address like before, but now we are inside of the first interrupt routine. So we load the new address. We increment the DO12, that is the register with the number of raster line that we want to trigger the interrupt. We acknowledge the ERQ. So we basically we said to the C64, hey, we have served your interrupt.
Yeah.
Okay. This is a necessary, a needed trick. We must save pointer on X. We must save stack pointer on X register.
Yeah.
This instruction is a key because saving the stack pointer, we can roll back all we will made after. Okay. Now that we have saved the stack pointer, the stack pointer is a point is a value that say me where the stack is basically. Okay. Now we clear the interrupt, so we reactivate the interrupt inside an interrupt. Okay. So after that, another interrupt can trigger, but the next interrupt that will be triggered is the interrupt that we have set here and here. In fact, if we follow this line, we will see where the interrupt will be. What is where the interrupt called the our routine. Okay. After that, after the interrupter activation, we must wait for the interrupter with a series of NOP opcode to assure us that the interrupt occurs in one of these NOP operation, and the NOP operation that will be in which the interrupt will occur are one of the asterisk 1. In fact, if we count if we count where we are, okay, 21, 23, 27 to 28 to this is the range basically. Here we are from the 57 to the 64 cycle, but the 64 cycle is the first cycle of the line 29. So from here to here, the interrupt will be occur for sure. When the interrupt occurs here, the CPU jump to here, to the ERQ stabilizer, and at this point our jitter will be 1, 0 or 1 cycle.
Okay. You finished this part, or there is more to it?
No. Can you explain better what?
Yes, but I'm going to give you a break. Okay, so I'm just going to talk about something else, and then I do a revision of what Emanuele did. So I am going to show this game. Okay, this game was done by Old School Coder. Okay, he does coding for the Commodore 64. He is doing a really nice job. Honestly, he is top when it comes to coding the Commodore 64. This game was done for the VIC-20, and he converted it for the 64, C128, 16, and to the Mega 65. And the Mega 65 is not ready yet. And yesterday he started the BBC version. Okay. He did the pet also. Yeah, I forgot to mention the pet. He did it also for the pet. Now, I was not always following this, okay, but this is really it's impressive how, for me, converted such a game to all these machines using what I normally use, but the way he configured the extension is really cool, I have to say, and I need to learn how to configure the extension like he did. But I do, if you like the Commodore 64, if you like to code for the Commodore 64, I encourage you to follow Old School Coder. I don't know if the ISO will let me. Yeah, please follow Old School Coder. He is really doing things related to the Commodore 64, really helping the Commodore community. He helped me many times, and same, I believe, with Dockster. So please follow Old School Coder. So let me start the game. So I'm not good at playing, okay? I'm just going to play it once, twice, and that's it. I need to click in the window. Okay. Now I'm using, I think, oops, there you go. There's a lot of things happening on the screen, okay? Oh, this I need to take, I think.
It's very impressive.
Yeah. And this is from a game for the VIC2. He did this for the Commodore. He enhanced it, I think. There are more objects. But, yeah. Oh, I cleared the level. Oh my god. I cleared the level. No.
You become good.
No. I'm still crap. There you go. This is hard, that you have to start the game with the same... Jesus. There you go. I played one more. In the name of Old School Coder. I believe this does something. So, guys, this, somebody suggested for me to do this for the Amiga. Not going to say who. But I haven't decided yet if I'll do it or not. Because I do not think I have all the time that I need. This requires quite some time. Oh no, this I need to take. No. There you go. Anyway, guys, follow Old School Coder.
Absolutely.
Yeah, Andy, there will be another game after Let's Make an Amiga series. Yeah, there is going to be another game. Right now I'm doing the intro, and there I am planning another game, and it will happen. It will happen. Yeah. So the Let's Make an Amiga game hasn't finished. We will do another game for sure. I mean, I take the advantage of programming for the Amiga while streaming it. Why not? But I do not want to do a game that takes a lot of episodes also, because if it takes a lot of episodes, I'm afraid that people will stop following me, and the Amiga is not like the Commodore 64. It's more difficult, no? So keep it simple. But yeah, so let's explain what Emanuele did. So where were we? Here. So we already said that when the interrupt happens and we save the registers, okay, we have used 7 for the interrupt, plus it saves the status register, and 13. So that means we are somewhere between cycle 20 to 27, okay? And Emanuele, let me...
Sorry.
No, it was my fault. I forgot to take control. So we need to correct this because we have 7 cycles. We could have 7 cycles difference. So we point the raster vector again, sorry, the interrupt vector again, to a second raster interrupt routine, okay, which Emanuele called IRQ stabilizer. However, remember, we are on line raster line 28. So we need to trigger this on raster line 29. Okay? So he sets the new interrupt routine. Then he increment the raster. So we were 28 and he incremented to 29. Okay? He acknowledged the interrupt. Okay? So he told the Commodore receiver, hey, I did the interrupt. We are telling him we did the interrupt. And then we need to save the stack. That's the stack pointer, no? Yeah. Save the stack pointer
Yes.
to the X register. Okay, this is quite important. And then we enable it. And I can show the image. I do not have anything else, but I can show the image, Dockster. But yes, just after I finish this, I had the intention. So once he saves the stack pointer, we enable the interrupts again. So remember, we enable the interrupts, the raster interrupt, when we are still on raster line 28. However, Emanuele created a series of no-ops. Remember, every no-op is 2 cycles. So when the interrupt happens for raster line 29, it can either be, we can be either in an offset of 0 or 1 because no-op takes 2 cycles. Okay, so it can be at 0 or it can be a 1. So once the no-ops are done, where did you finish, Emanuele? Here, no? Till here you finished?
Yes.
Yeah.
I finished here.
Yeah. So remember,
Here.
remember here we are still on line 28, but we are jumping into line 29 now. Okay, so look, this is raster line 29. Now, before Emanuele continues, I need to show what Dockster is doing. I don't. How did we start this idea? I mean, you came up with the idea, right? I mean, I forgot how it happened. But no, I'm not bored. I'm very concentrated, to be honest. So my friend from Megastyle, okay? Everybody knows the Kefren's IFF converter, okay? Yes, that's how it happened. Now I remember. So what happened was that, to convert an image into from IFF to something else, you need to start the Amiga and load the image in the IFF converter and convert it into RAW, because this is what the Amiga understands, raw images. So Dockster came up with the idea of writing this on Windows, writing something like the IFF converter on Windows, and this is the initial image, let's say, of it. I mean, we are discussing it in a way, but he's doing the work, not I. I mean, I'm just, annoying him with my requests. Let's put it this way. Right, Dockster? So yesterday he managed to load an IFF image and in the in the editor. So basically he has a routine that converts that is able to read an IFF image and loads it in on a Windows machine, basically. So yeah, looking forward for this, and definitely I will be showing more of it. And you know, guys, this is very important for when you are writing games. You need, I mean, I'm constantly using the Amiga too to do these things, but it would be nice if I can do it on Windows. So yeah, well done, Dockster. So Emanuele, I'm going to give you back
Can I continue?
Yeah, and I give you control, and you can continue.
Okay. Now we are in the ERQ stabilizer called by our second interrupt in the line 29 with a jitter of 1. The ERQ used 7 cycle for the interrupt use 7 cycle for its things, saving his status, etc. And 0 or 1 cycle only was used to complete the last operation. That is an op for sure, because we are constructed, we are builded. Sorry, mamma mia. Hey, sorry.
Mamma mia, yes, Emanuele.
Okay, we have built this thing. Okay. So we have only 1 cycle jitter. We are therefore positioned after R29 in the 7th or 8th cycle, and now we must reset the stack pointer with the value that it has before our second interrupt. In this way, the CPU believe it never happened, and this is the tricky to
Yeah,
the
this
the
is the
tricky
trick, basically.
to close this call. Sorry.
Yeah, this is the trick.
Okay. Now we are in the row 29 in the 9th or 10th cycle, and now we must reach the 13 rows with a jitter of 0. So our goal now is to reach the 0 jitter. Okay. In order to achieve this, we must build a loop like this to consume 41 cycle, waiting the 41 cycle. Consuming is another word.
My friend.
So we reach the okay. This is a simple cycle. We load a counter with the value of 8, and we decrement this counter until it's 0, looping here. At the end, we have reached the the row 29 at the 50 or 51 cycle. Now we use I added free no operation opcodes, and now we are very near to the edge of the 29 raster line. To get the 64 cycles, that is the first cycle of the row 13, and reach the row 13 CO3, the third cycle of the row 13, we have to use another 8 or 9 cycles, depending on the guitar. If the guitar is 1, we should use other 8 cycles. If guitar is 0, we will use 9 cycles. Anyway, we landing in the same place, in the same address, ending address. The degree of precision we will have be bitter 0 or 1. In the next line, we will be able to reduce the guitar to 0, and we will synchronize in the row 30 third cycle anyway. If even if we have 0 or 1 cycle. So we are still in the line 29, in the 56th or 57th cycle. We now
Emanuele, let me explain this.
Okay.
Okay, so you can have a breath and start thinking about how to say that.
Thank you.
So we set an interrupt to happen on raster line 29, okay, and we use the no ops to fill let's say the gap of a one scale line, okay. So when interrupt for raster line 29 happens, okay, we are offset now, okay, by, so there is 7 cycles for when it stores the address and for storing the status register, and then there is an offset. Where did it here? So we will have an offset of, because remember it will happen in a no op. Where did it go? Sorry, I forgot to take control. So the interrupt will happen somewhere here, no? Because remember the raster line length is 63, but we are exceeding that, so it will happen somewhere there. So we will be offset now. Our correction will be either a 1 or a 2, because we know that there are 7 cycles when the interrupt happens, okay, and there are 2 cycles, okay, for the no op. So basically it's a 9, but we could be either 9 or 10 because it depends where it happens on this. So it could be in the first cycle of it or in the second cycle of it. Hence, we have reduced it from a difference of 7 or 8, I forgot how much it was, to a 1 or 2, okay? So when we are on raster line 29, okay, we create a delay loop of 41 cycles, okay? Now, this branch on not equal varies by 1 or 0. Okay, so if the 0 flag is not set, it's 3. If it's set, it is 2 cycles. Because of this difference, it gives us the permission, okay, to fix this offset that we have, which can either be at 0 or a 1. Okay, because we have an offset of 0 or 1, whichever that happens, okay, then he adds more. So we are on cycle 50 when we reach cycle 50 or 51 when we reach here. Okay, so he add more no ops. Okay, and he's still on raster line 29. Okay, and he is somewhere 56 or 57. Okay, so now he's going to fix the part that we were saying. Okay, Emanuele.
Okay. Now we built the 8 or 9 cycle consuming routine following the jitter value. If the jitter value will be 1, our routine should consume 8 cycles. If the jitter will be 0, our routine should consume 9 cycles. To do this, we use the trick that I'm trying to explain you. In the next line of codes, it has at the right edge of the raster line 29. It can start from cycle 29 or 16. If we add 4 more cycles, it will end at 62 or 63 cycle. So we are at the very edge of the our raster line.
Yeah.
At the end, the next opcode, CMP raster, could start at 63 or 74. 63 if jitter will be 0. 74 if will be 1. So our trick start from here. Our trick start from here. We load the value of the raster that we know we are in the 29 line, but reading with this opcode, we are consuming 4 cycles. So at the end of this the value of the accumulator can be 29 or can be 30. Okay. At this opcode, okay.
So you want me to explain this part?
See, yes.
Okay, so when this instruction
because I'm troppo lento, sono troppo lento adesso.
No, it's okay. Just drink and we continue. We'll finish it. Don't worry. So when this instruction is executed, okay, we can be, so if you're at 4, this instruction takes 4 cycles. If we are on cycle 59, we arrive till the end and we start from 0 for the next one. Or we start from 1. Okay, so for the next line, remember we are on raster line 29 now. Okay, so we're going to start the 30. Okay, so what he's going to do is do basically a compare. Let's put it this way. And notice, if we are not
No, sorry. The load accumulator will be in the 29 anyway.
yes,
Uh,
yes,
uh,
yes, yes, we are on the 29. That's what I
okay,
said. So
okay,
if
okay,
we
okay.
if we are okay on raster line 29, we do a branch on equal and we go down here. If we are not, okay, we skip this one and we come down here. So this is our stabilized, raster. This is what causes the raster line to be stabilized. Emanuele, do you want to continue? Because I feel, I can continue to explain it, but I think you should. It's your job at the end.
Okay, okay. We load the raster. We compare the raster, but when we are comparing the raster in this line, we can uh, we can stay in 29 or 30,
Yeah,
13 rows.
yeah,
So the trick is here. Our trick is to make a BAQ branch for equal to my ERQ, but my ERQ is exactly
instruction.
the next instruction. So even if BRQ is true or false, the next instruction will be executed. The difference is the number of cycle used, and this is the trick. So if if BAQ MyRQ is false, it uses only two extraction. If is true, it it will use
Three.
free cycle, and the BAQ will be false if the getter will be one, and it will be true if the getter is zero. In this way, we have a getter of sure zero for sure. Summing up, now I am reading. If we arrive at routine 8 or 9 with 56 cycles, then the R29C 60 56 plus 8 plus free cycle used. The free are because
Yeah.
there is the true. Okay. The 8 is the 4 plus 4. Okay. We reach the R row 13 cycle 2. If we get to the routine 8 or 9 with 75 57 cycles, the if the row 29 with the cycle 57 plus 8 plus 2, because BAQ was false, the landing row will be again 13 on second cycle, on third cycle
So
number
so
2.
basically, so basically, when we arrive here, okay, this part, okay, when we arrive here. When you add these two, which is 8 cycles, plus whether it's 2 or 3, okay, we will always be, okay, on raster line 30, cycle 2, okay? So that's where our stabilized raster starts, because now we have it stabilized. It's at the same position always, okay? So
Yes.
now, then what happens is what we have already done before, but I leave it up to him to explain it. But you have seen the part that follows, or part of it, let's put it this way. I'm still saying I'm following an Emanuele, that's why. Okay. So, being here, okay, being here, till here, we are now on line 30, cycle 2. So we have stabilized the raster by playing with these instructions to make them, let's say, to make the raster happen in always at the same time, or not happen at always at the same time, to make it start always at the same time. That's the thing. And remember, we have a raster interrupt and it calls another interrupt. Okay, Emanuele.
Okay.
I give you control.
Thank you. Now we have raster stabilized. We are here for sure. In row 30, cycle 3, that is the first operation. Our first operation will be will start from cycle 3. Okay, our goal is simply to draw a line from the 14 for the 14 cycle to the 24 cycle. So the first thing I made is to losing some cycle, an op to reach the 50th cycle. I made LDY 42X to lose an even number, an odd number of cycle, 3 in this case. There is absolutely random. This value isn't important. Now we want to make a simple line. So the first thing I do is increment the border register on the VIC, that is DO20. Okay, now I am on 14th cycle, so I made some NOP, and the last one I am decrementing the register for the border, coming back to the preceding color. So I have a total of 10 cycle long line. So I said to the C64 again, hey, I made I do all things for this raster for
We acknowledge the
this
interrupt
raster.
there. We are acknowledging the interrupt.
Okay, and acknowledge the interrupt. Using this tricky opcode that is explained here, why I use and all coder use this this
Yeah,
opcode is a little tricky to zeroing the ERQ register with only one opcode.
Yeah, this was explained in episode 3, I believe.
Yes,
Yeah,
yes.
and what it does, ASL, it's always writes a 1 first. So
Anyway, is brighter.
yeah, and then it writes, the value. So first it converts everything to 1, and then it writes the value. Because it does this right, we are acknowledging the interrupt basically. So it's a fast way of acknowledging the interrupt instead of doing end or things like that.
Yes. The last thing that we have to do is setting again the pre-MyRQ interrupt to prepare the next interrupt for the next frame. So this part is identical to the part that I wrote here. Okay. In fact, I load the pre-MyRQ lower and higher byte, storing it to FFFA and FFFFF. Set raster line where 28, where we reach where we want display the raster, and after that we will restore the Y, X, and A register in the reversing order that we have saved here. Okay. Last thing, we made a return from interrupt.
Okay.
That's all.
Okay. So let me explain it, the last bit. So we arrived at the stable raster line, okay, which we are in cycle 2, right? So we start at cycle 3. He has this random value there, whatever, to have 5 cycles. Now I assume losing 5 cycles. Then he increments the border. So let me actually execute to explain better. Let me show you the Commodore 64. So because we were in a 3, he wanted to start later, no? So he wasted some cycles. Then we did, so this is blue, no? Where the raster line is. We told it increment by 1. The next color after this color is the gray color, okay? So we increment what there is in the 020 by 1, okay? We wasted some cycles again, and then we decremented. So if we decremented it, we turn into blue again. And that is our line on the screen. But we haven't finished, the routine haven't finished. So we need to acknowledge the interrupt. I shouldn't click. We need to acknowledge the interrupt, okay? And we explained why we are using ASL, and if so, if you forgot, just read the comment there. I mean, the code is going to be shared, okay? With each episode, I give the code, so you can have a look at the code anyway. Then, remember, we changed our interrupt routine, okay? to the stabilized routine. But now we have to return back to our old interrupt routine, okay? So that it can execute more than once if we want to, which I will show you what I mean. So we return to the first interrupt routine, okay, that we had, that was doing the calculation, okay, that starts at raster line 28, okay. We change the vector, okay. We set at which raster line we want to start, raster line 28 again here, okay. We are telling it we need to start at raster line, and we need to restore the registers back, and then we return from the interrupt. So we have an interrupt that creates another interrupt, okay, to stabilize the raster, and then once we've done it, we return back to the previous interrupt, okay, we set everything back to the previous interrupt, and we exit. That's all what we are doing. Of course, we have included this nice little line to show that we have a stable interrupt, but next week we will show, by having that, what we will be able to do.
No, next week we have the
No.
PONG game.
Yeah, after the PONG challenge, okay, you can see that same line moving up and down now. Okay, so
Can
that's the
you
first.
show? Okay.
So that's the first thing that we have. Then I do not want to go in detail, Emanuele, but yeah.
Yeah, okay.
And then we have my lovely thing of the Amiga, but on the Commodore 64. Okay? We can do copper bars. Okay? But there is no copper bars, it's raster bars. Okay? So, but it's all available if you have a stable raster. Okay? So now that you know the trick, okay, and you will get the code, you can learn this, and then you can start doing these things. Raster, the stable raster, we will show other stuff what is very useful that you should know so that you can do certain tricks on the Commodore. Without it, you cannot do them. Okay? So, for example, one of them is using the DSP back scroll, horizontal scroll. Okay? All these things, but it's having a stable raster.
Yes.
Okay, so guys, this is where we stop. So guys, thank you very much. Please stay with me till the raid starts. And hope to see you next Tuesday for the PONG challenge, showing you the PONG games. Thank you. Bye-bye.
Next Tuesday.
Bye-bye.
The next Tuesday. Bye-bye all.
Bye-bye. Bye-bye.